So this is Jeff Hamrick at Rhodes College, and I'm going to talk for a few minutes about using a randomization procedure, namely sampling with replacement, to estimate the confidence interval for the difference in two means. We have here some data related to whether or not a student at Rhodes College affiliated with the Greek system during his or her first year, or whether that student chose not to do so. And then the other piece of data that we have is the cumulative GPA of that student at the end of the first year. A superficial analysis of this data suggests that there's a slight tendency of non-Greek students to have a higher GPA at the end of the first year. We've already validated that this difference can't be explained due to random experimental variation already using a hypothesis test. And now what we'd like to do is build a confidence interval for the true difference in the means of these two different groups of students. So here's how we do so. The first thing we're going to do, this is a little bit different than what we've done previously, is I'm going to add two additional attributes to this raw data. One attribute column will be called Greeks. The other attribute column will be called non-Greeks. Okay? And here's the formula that I'm going to put into this column. I'm going to put the formula if affiliation is equal to Greek, then take the cumulative GPA, that is the item from this attribute column. If the affiliation in the appropriate row is not equal to Greek, then just insert a blank string. Okay? And so it simply moves over the data in this cumulative GPA attribute column unless the leftmost column, the affiliation column, is not Greek. For example, in this case, it did not move that over. And that sort of indicates to you what this final attribute column is going to be. Use the formula if affiliation is equal to non-Greek, then take cumulative GPA. Otherwise, take a blank string. Okay? And we fill out the rest of these data for the non-Greek attribute column. Okay, we're going to do one other thing that's a little bit different than what we've usually done. I'm going to define a measure on the raw set of data that will then be inherited by my samples taken with replacement once I start generating those samples. So here's the measure we're going to create. I'm going to call this measure difference, and it's very simple. It's going to be the mean of the non-Greek GPAs minus the mean of the Greek GPAs. All right? So for the original set of data, that difference is 0.1172. That is, on average, non-Greek students have a cumulative GPA about 0.11 higher than a typical Greek student. Okay? So the philosophy behind this confidence interval construction will be the same as before. We're going to sample with replacement. All right? So I'm not going to turn this option off. I'll turn the animation off. I'll replace existing cases, but the number of cases that we're going to sample is going to be equal to the number of data points in the entire original study. So that's going to be 321 in this case. All right. So if you sample more cases here and then click on the Measures tab in the sample box, you see that it's inherited the measure that we defined on the original set of data, this box over here. Now when we sample with replacement, that difference is 0.09 instead of 0.11. If we sample with replacement again, we get this measure. We obviously want to collect many of these measures so we can have a sense as to how these measures vary under experimental chance. So I'm going to collect measures now by right-clicking, collecting measures, 1, 2, 3, 4, 5. That's not going to be enough. So what I'm going to do is turn this animation off. And I'm going to start the process of collecting a total of 1,000 measures. I'm going to finish up this screencast for right now, let these measures collect. In the second part of this screencast, we'll go on ahead and remind you how we compute the left and right bounds of, let's say, a 95% confidence interval for the true difference in means.